All right, ladies and gentlemen, so today we are learning B.2 Experimental and Theoretical Probability. So today we're going to be looking at developing probability models to use experimental and theoretical probability. We're going to explain the meanings of these probabilities, and then we're going to find their probabilities as well. And then we're going to use them to make predictions. And if you wonder, I am using the iPad here to take notes on the screen that you are seeing. So in class, we go through and are conducting 2 experiments. So if you're not in class, you could conduct these experiments on your own, or you can find a key of our class data and how we answered these questions and went through this experiment on the Canvas account. So these are just some questions that, again, there will be an exploration going through these experiments, and then there's a key on Canvas, okay, that you can find. A couple of definitions that we're going to be going through here. The first is experimental probability. So the definition of experimental probability is it's a probability that's based on repeated trials of an experiment. So some examples of an experimental probability would be what we did in that beginning exploration, where we flipped a coin and saw how many times we got heads or tails, and then we tossed the Hershey Kiss in the air and counted how many times it landed on its flat bottom or on its side. The way we calculate experimental probability is we look at the number of times an event occurred divided by the total number of trials. So very similar to our relative frequencies we calculated in the last lesson. Now there's some new notation here. This P stands for probability. And then this piece here that says event, that just means we're going to fill that in with whatever's going on in the question at hand. So if the question is asking us to find the probability of rolling a 2 on a number cube, we would write that inside of these parentheses to say that this is what we're finding the probability of. So we'll get some practice with that in the next couple of examples. The only other definition we have for today is for theoretical probability. So the definition of theoretical probability is, let me not do this in highlighter, it's the division of the number of favorable outcomes over the total number of possible outcomes. You're going to see us go through an example of this when we do example 2 here in the notes. So theoretical probability is saying in theory what's going to happen. So experimental probability is based on something that has happened, an experiment we conducted and we took our results from a table. Theoretical probability is just saying in theory what should happen. So think about this. If we flip a coin, there's 2 sides to a coin. There's heads and there's tails. Well, we could flip our coin 25 times like we did in the experiment at the beginning of this lesson, and we might get different results than if we thought about it in theory in terms of the probability of flipping heads. So the probability of flipping heads, well, there's only one head side of a coin. So 1 out of 2 is the probability of flipping heads, theoretically. In reality, are we always going to have 50% of the times we flip the coin we get heads and the other 50% we get tails? No. And so when you look at our experimental results of flipping a coin, you'll notice that it's likely not 50% that we get heads and 50% that we get tails. But in theory, that's what it should be. The way we calculate theoretical probability is very similar to experimental. So it's the number of favorable outcomes divided by total number of outcomes. So the number of favorable outcomes, the favorable piece is just whatever event it is that you're looking for. And you're counting how many times does that event occur within whatever the context of the problem is. So we'll go through a specific example of this in example 2 in the notes. So let's work through example 1, finding an experimental probability. So this is an example of experimental probability. The question says, the table shows the results of spinning a penny 25 times. 6 times we got heads and 19 times we got tails. It says, what is the experimental probability of spinning heads? So the event they give us is spinning heads. So when we go to write this out, we will use a capital P that stands for probability, and it's the probability that we get heads when we spin the penny. Well, the total number of times we got heads, according to this table, is 6. Now, the denominator is the number of times we spun the penny altogether, whether we got heads or tails. And so if we take 6 and 19 and combine them together, we get 25. Or it says it in the problem that we spun it a total of 25 times. But out of those 25 times, it landed on heads 6 times. So our probability of spinning heads based upon these results from an experiment is 6 divided by 25. You could write this as a decimal of 0.24, or you could write it as a percentage of 24%. And that would be our answer. So practicing finding an experimental probability, I want you to take a moment to pause the video and see if you can find the answers to these questions of rolling a 3 and rolling an odd number. Press play when you're ready to see the answers. Alright, so hopefully you've paused the video. It says the table shows the results of rolling a number cube 50 times. So we know we rolled it a total of 50 times. Find the experimental probability of each event. The first event is rolling a 3. So the probability of rolling a 3 is going to equal, we got to figure out, well, how many times did we roll a 3? The frequency is telling you how often that happened. So we rolled a 3 8 times according to the table. So I'm going to take 8 divided by the total number of rolls, which the problem told us was 50. In decimal form, you could write that in decimal form, or you could leave it as a fraction. You could reduce that down to 4 to 25. So with probability, you can write your answer as a fraction, a decimal, or a percent. Any of them are fine. So looking at the next one, the probability of rolling an odd number. First, we have to think about what are our odd numbers. Our odd numbers are things like 1, 3, and 5. So when we're looking at the probability of rolling odd, we have to look at how often, according to this table, did we roll a 1, 3, and 5. Well, we rolled a 1 10 times. We rolled a 3 8 times. And we rolled a 5 11 times. Out of a total of 50 rolls altogether. And that gives us 29 out of 50 for the probability. So this is where this video is going to end. Go to the next video to see the rest of the examples.